So for our lesson today, we are going to solve exponential equations. For an exponential equation, we're going to have a base with an exponent on more than likely both sides of our equation. In order to solve them, we need to rewrite both sides of the equation with the same base. So you'll see in this example here, the bases are both 6. When that happens, we can cancel them out and set the exponents equal to each other and solve for the variable. So if we were to finish this problem, we would take 5 plus y equals 3, again, because we're canceling these out. To solve for y, you would just subtract 5 from both sides to get y equals -2. And that would be your solution. So again, I've written you a reminder, if our two terms in the equation have the same base, we know that the exponents must be equal. So for question number 1, we have 5 to the x power equals 5 to the 4th power. When we compare these, our bases are exactly the same, so we can cancel them out. That actually just leaves us with x equals 4. Question number 2, if we have 6 to the 5 plus y power equals 6 to the 3rd, we're checking to make sure that our bases here are exactly the same. Since they are, we're going to cancel them out. 5 plus y equals 3. Subtract 5 from both sides, and y equals -2. This was actually the problem from that first page. For question number 3, when I look at my bases, I have bases of 4s on both sides. I'm going to cancel those out, leaving us with x minus 5 on the left equals 3x plus 13 on the right side. In order to solve for x, I would subtract x from both sides to combine them. So -5 equals 2x plus 13. We would subtract 13 from both sides next. So -18 equals 2x. Divide both sides by 2. And x equals -9 would be my answer. All right, so those are best case scenarios where we have like bases. On this one, however, we have a base of 6 on the left-hand side, but the right-hand side does not have a base of 6. So in this situation, we want to rewrite each side so that it has the same base. So we're going to have to rewrite the 1,296 so that we have 6 to the something power. So I want you to pull out your calculator and we're going to start experimenting. So I need to figure out 6 to the what power is 1,296. So in your calculator, you're going to type 6 caret key and then you're going to pick a number. So if you pick 6 to the second power, you're going to get 36. That's not big enough. So then I would go 6 to the third. If 6 to the third is not big enough, I would go 6 to the fourth. If 6 to the fourth isn't big enough, do 6 to the fifth until, again, you get one that works. It is indeed 6 to the fourth. So I'm going to rewrite this as 6 to the fourth power. So I have 6 to the 3x plus 1 equals 6 to the fourth. Now that we have like bases, both these bases are 6s, we may cancel them out. That's going to leave us with 3x plus 1 equals 4. And now we have an algebraic equation in which we can solve for x. So in order to solve for x, we're going to subtract 1 from both sides. 3x equals 3. Beside it, divide it. X equals 1. Final answer. Aha. So for this next one, again, we want to rewrite these so that they have like bases. So in order to rewrite the right side so that it has a base of 6, I want you to experiment and figure out 6 to the what power will give you 1. I'll give you a hint. 6 to the first power is 6, so it's too big. If 1's too big, what number would you try next? Anybody figure it out? 6 to the what power is 1? It is 0. If you don't believe me, take 6 caret key 0 in your calculator. Anything to the 0 power is 1. So if I'm ever given a 1 in an equation and I want it to have the same base as the other side, I just take that base and write it on the other side with a 0 exponent. Again, anything to the 0 power is 1. So now I have like bases I can cancel out. And I need to solve the equation 3x plus 1 equals 0. Yep. So we're going to subtract 1 from both sides to get 3x equals negative 1. Divide both sides by 3 to x equals negative 1/3. Questions on this one? may or may not be a test question on your next test where you have a 1 on one side, and you've got to remember that you can rewrite it to whatever base you want with an exponent of 0. All right. The next unusual scenario that happens is when we have a fraction. So we need to rewrite the right side to have a base of 5. The first thing I want you to figure out is 5 to the what power gives us that 625. So in your calculator, do some experimenting and figure out 5 to the what power is 625. Yep. So in this case, 625 is 5 to the 4th power. Maybe. In order to get this 5 to the 4th out of the fraction, to move that 5 to the 4th to the top to get rid of the fraction, we need to make the exponent negative. So I actually would leave the left side the same. So 4 minus x is your exponent. And then on the right side, we're going to have 5 to the negative 4th power. If you type 5 caret key negative 4 in your calculator, you're going to get a decimal. You will get the same exact decimal if you type 1 divided by 625 in your calculator. Again, if you don't believe me, type it in your calculator. I promise it's true. So now we have like bases of 5s. So both of these 5s here are going to cancel. That's going to leave us with 4 minus x equals negative 4. I would subtract 4 from both sides. That's going to give me negative x equals negative 8. That negative in front of x is like a negative 1. To get rid of it, we're going to divide by it. So x equals 8. And that right there is your final answer. Oops. Making things a little bit more challenging. Sometimes you'll have to change one or both bases. And if they already have exponents, things are a little bit trickier. So for this first question on the left, we have 2 to the power of x plus 3 equals 4 to the power of x minus 2. If I want to rewrite these as the same base, I first of all notice that I can rewrite 4 as 2 squared, right? 2 squared is the same thing as 4, and that would get me a like base. But when I rewrite that, I have to put my 2 to the 2nd power, and then anything that was already an exponent must go in parentheses. So that x minus 2 has to go into a set of parentheses. Very important that you put those parentheses around the x minus 2. So now my bases here are both 2. Since the bases are the same, we can cancel, leaving us with x plus 3 equals 2 times x minus 2. And then to solve this, we're going to distribute to get rid of our parentheses. So x plus 3 equals 2x minus 4. Now I want to get x by itself, so I would subtract x from both sides. Oops. That's going to give me 3 equals x minus 4. I'm going to add 4 to both sides. And that's going to give me an answer of x equals 7. Questions on this one? So key thing here is we had to put parentheses around the exponent that was already there when we put a new exponent up top. For the question on the right-hand side, I have a base of 25 and a base of 125. If I try to rewrite the larger base to match the smaller one like we did on the last problem, it's not going to work. You can't take 25 to the something power and get 125. So this is a situation where you're going to need to rewrite both bases. So if I ask you to rewrite 25, what would you rewrite it as? What to the what power is 25 most commonly? So most commonly 25 is written as 5 squared because 5 times 5 is 25. And then remember, like before, the exponent that was there previously must get written in parentheses. So 5 to the second power, and then in parentheses, the x minus 1. For the right-hand side, I need to rewrite this to also have a base of 5. 5 to the what power is 125. So 5 to the third is 125. So 5 to the third gets written, and then anything that was already an exponent is getting put into parentheses, in this case, the 4x. Now I can cancel out my bases because they are exactly the same. So they're both 5s here. I can cancel them both out. I'm going to have 2 times x minus 1 in parentheses equals 3 times 4x in parentheses. Now we're going to distribute to get rid of our parentheses. I'm going to take 2 times x to get 2x, 2 times -1 to get -2. And then on the right-hand side, 3 times 4x, which is 12x. In order to get x by itself, I need to start off by subtracting 2x from both sides. So -2 equals 10x. To get rid of that 10, I'm going to divide both sides by 10. That's going to give me x equals -2 over 10, which needs reduced to -1/5. So that right there would be our final answer, -1/5. The next thing we're going to look at is using exponentials in real world. This is the formula for compound interest. So compound interest means that you're earning interest multiple times throughout the year, not just one time at the end of the year like normal. So you're going to be given this formula on your final exam. There is a question where you must use the compound interest formula. Down here at the bottom, you'll see A stands for the amount of the future value, including the interest that you're earning. So a lot of times we use Y there, but A is what you're going to be given on your test, so that's why you're being shown it this way. P is the principal and investment amount, the initial deposit, or a lot of times it's a loan amount, so that's your initial value. R is going to be your interest rate. As a decimal, you can, like we talked about yesterday, type it in your calculator as a percent. N is going to be new here, so N is going to be the number of times that you're earning interest. So this right here and this right here are going to be the only things that are really different from what we did yesterday. T is still going to be the time that your money's being borrowed or invested. All of these problems are going to deal with money. So our simple interest formula that we used yesterday dealt with populations and other things. Your compound interest formula is generally going to be just talking about money. So I put this little blurb in here about compound interest. It did not copy very well, but we're going to run through it. So this region right here at the bottom, this is your principal amount through this entire 20 years. So your principal amount stays the same. It's not ever going to change. If you invested, in this case, $1,000, that $1,000 is going to stay in your account forever. Your simple interest is this region right here. So your simple interest, you're gaining the same amount of money every year on that $1,000 for the entire length, in this case, 20 years. Compound interest comes into play because you're going to earn interest every year on the interest that you earned the previous year. So this is where you can earn a lot of extra money pretty quickly. So the difference here is quite substantial. That compound interest, you're earning money on the interest that you gave the previous year. So let's try it. We're going to compute the value for an investment after 10 years. If an amount of $5,000 is deposited into a savings account that earns interest at a rate of 5% compounded monthly. So first thing we're going to do is go through and identify the parts and pieces that we're going to need for the formula. So P is your principal or your initial amount. Initial amount in this case is $5,000. Your R, your rate in this case is 5%. N is the new piece to this equation. N stands for the number of times that interest is compounded. You're told that interest is compounded monthly. How many months are in a year? Everybody says 12, because everybody's paying attention. So compounded monthly means you're going to be earning interest 12 times per year, and your time is 10 years. So now we're going to go back to that equation. Our amount or our Y value is going to be equal to the principal, P, 5,000, parenthesis 1 plus. In our formula, we need R divided by N. So we're going to take 5% divided by 12, close our parenthesis, and then we need N times T. You have two options. I would just go ahead and multiply N times T for my exponent. I would write 120 up there. But if you choose not to, you must put it in parentheses 10 times 20. 12? I think I said 20, I meant 12. So 10 years, 12 times per year. So these you have to be really careful when you type them in your calculators. You're going to start off with 5,000. Parenthesis 1 plus 5% divided by 12. Close your parenthesis. Then your caret key, parenthesis 10 times 12, close your parenthesis. So when you type that in your calculator, you'll get an amount of $8,235.05. Questions on this one? All right, question number 2. A newborn receives $20,000 as a gift towards college education from her grandparents. How much will that $20,000 be worth in 17 years if it's invested at 7% and compounded quarterly? So I'm going to make my list over to the side. I need to find P, R, N, and T. So P, the initial amount, your principal amount is the $20,000. Your R stands for your rate, 7%. N stands for the number of times your money will be compounded in a year. So here I'm told compounded quarterly. Quarterly means 4 times per year. Think there's 4 quarters in a dollar. There are 4 quarters in a year. And our time is 17 years. So then I'm going to plug all of this information into my formula. Our amount is going to equal the principal, 20,000, parenthesis 1 plus, because we're earning money, 7% divided by 4, all to the 4 times 17 power. Again, if I were doing this, I would type 4 times 17 in my calculator, figure out what that is, and then use that as my exponent. But you can type it all in there all at once. Again, you must use parentheses in order to get the correct answer. So when you type this in your calculator, you should be getting a value of $65,068.44. This is again contingent on all of that money. The original investment must be left in there for the entire 17 years and continuously earn that 7% interest compounded quarterly. So for question number 3, at age 27, Jill deposited $4,000 into an IRA, an individual retirement account, where it earns 9.8% interest compounded semi-annually. What will this be worth when she is 35? So we're going to start out with those same 4 pieces of information: P, R, N, and T. P is the principal, the initial amount that Jill is investing, so $4,000. R is the rate, the interest rate that Jill is earning, 9.8%. N is the number of times that she's going to be earning interest. Here, my keyword is semi-annually. Semi-annually means 2 times per year. And she's keeping that in there from age 27 to age 35, which is 8 years. So then we're just jumping back over to that formula. The amount in her account is going to be equal to P, and then in parentheses, 1 plus R divided by N, so 9.8% divided by 2, all to the 2 times 8 power, the N times T power. So again, we can type this all in our calculator if we're being very careful, making sure we use all of these parentheses where necessary. Both sets of parentheses in this case are necessary. So you should get a value of $8,599.39. So after 8 years, Jill's initial investment will have over doubled in value. Last one down here at the bottom is about as tricky as they can get. So imagine a $500 account compounded daily at 3.2% interest for 19 years. They've changed the question that they're asking you. They're asking you how much interest was earned, not the amount of money in the account at the end of that time. So for this one, we're going to need to find the amount of money that's going to be in the account after 19 years, and then subtract the initial investment, the money that was deposited, to figure out how much interest is going to be earned. So we're still going to start out finding the principal, the rate, the number of times it's going to be compounded, and the time. So P, the amount of money invested, your principal is $500. The interest rate, R, is 3.2%. The number of times that it's compounded, it says daily. So you need to know that there are 365 days in a year. And the time frame is 19 years. So our equation is going to be 500 and then in parentheses 1 plus 3.2% divided by 365. Our exponent is the number of times it's compounded times the number of years, 365 times 19. So again, very carefully type this in your calculator. You should get an amount of $918.35. Again, this is the total amount of money in the account after 19 years. We need to subtract the initial investment, $500. So this is our initial investment. That's not money that was earned. That was money that was deposited. So we're going to take the 918 and subtract the 500 to figure out that there were $418.35 earned in interest. So final answer for this one is the $418.35. That is the amount of money that this individual has earned in interest. So the 918 is not the amount of money earned in interest because 500 of that was money that the individual had deposited.